Alright, hi there. This is Dr. Matthew J. Traum from Engineer Inc. This is the second video in the series of videos I'm making to show you guys how to set up a simple static model for elastic deformation in ANSYS finite element package. The first video that we did looked at a hand calculation for the geometry of interest. In the second video, I'll show you how to begin to set up the ANSYS model, and I'll let the video run for about 10 minutes and then I'll stop. That'll give you a chance to get caught up, take a break if you need to, and then we'll start another video and we'll continue that until we get to the end of the lesson. So what I've done is downloaded the student version of ANSYS 18.2 onto my personal computer. I am speaking to you now in October 2017. This is the most current version of ANSYS, and the beauty of it is that if you are a student, you can go to the ANSYS website, you can download the software, and you can follow along with what I'm doing here without having to pay any licensing fees. So that's a neat feature. Okay, so I've identified Workbench, which is kind of a multi-component tool used for finite element analysis within the ANSYS environment. So I will double click on this application and let ANSYS start up. Now I should mention the computer that this is running on is a personal computer that was originally purchased for like email and word processing, so it's not particularly fast or powerful, so you might see some lag in my system that you wouldn't experience if you had a purpose-built say desktop computer that was meant for finite element analysis. But anyway, it'll give me a chance to kind of fill in the missing pieces with commentary as we're waiting for the computer to crank through the calculations. Anyway, this is the Workbench project screen. So project schematic here gives you an overview of all the components that you're modeling and fitting together within the ANSYS environment. For mechanics of materials model, the one that we're interested in is the static structural analysis system. So I'm going to double click on static structural. It will think about it for a moment and then it will drop a static structural module into my project schematic. And notice that there's a series of numbers. This is essentially a list of all the things that you need to do to make this a valid component within the project schematic. And every piece that's missing is indicated by a question mark. So geometry is missing, the model is missing, the setup is missing. The only thing that's known is the engineering data, and we're even going to go in and change that because it's just set to a default value, which is not the material that we modeled when we did the hand calculation in the first video. So to access all of these, you just double click on them. So I'm going to double click on engineering data, and what comes up is a library of information, various materials that have been entered into the library and are part of ANSYS. So the default is structural steel, which is selected here. And as you can see, ANSYS has its density, its coefficient of thermal expansion, its Young's modulus, its yield strength, and so forth, all kind of preset into this library. Now, we used an aluminum alloy, not structural steel, and so we need to find the equivalent information for aluminum and set ourselves up to allow selection of that aluminum alloy when we get into the modeling process. So the way to do that is to go to Engineering Data Sources, hover over this and click on it, and all of the libraries that are preloaded with ANSYS will come up. Aluminum alloy is a pretty common material, so we're just going to look here under General Materials, click this, and a whole series of them come up. It's of course fixated on structural steel since that's the default. They're listed alphabetically, so if I scroll up, here's air, here's aluminum alloy, here's concrete, aluminum alloy. Okay, so this is the one that I want. To select it, I'm going to hit this yellow plus button, and it's going to, for some reason, default back down to structural steel. That one's already been selected. You know, by the way, that an option is selected if you see this little book appear in column C. So we're going to go back up to aluminum where we just clicked that little button, and notice this little book now has shown up in column C. And so what that means is we get into the modeling phase of the process, aluminum alloy will be available to us as one of the options to use for the material for our model. So that's set. Now to get out of this, I'm just going to go back to the project tab and click on it. Engineering data was already set, so that already had a check mark, but now we've expanded it to allow an aluminum alloy to be the material of choice. So the next step is to set up the geometry. So I'm going to double click on geometry, and it's going to start SpaceClaim. Again, this is not the fastest computer in the world, so it's going to take just a little while. SpaceClaim is the 3D modeling package that's built into a native within the ANSYS environment. Now you could draw a three-dimensional model in something like SolidWorks or ProEngineer and import it into ANSYS. However, I'm assuming that you don't have that software on your computer, that you've only downloaded the student version of ANSYS, and so we will just use the tools available within ANSYS to do our geometry. And the geometry is pretty simple, so it can be done within ANSYS, but once you get more complicated, you might want to consider SolidWorks, for example, to draw that 3D geometry. Okay, so this is the welcome screen, so I'm just going to close this. So essentially what we're looking at is a 2D representation of a 3D space, just like any other computer-assisted drafting or drawing package that you might be familiar with. So we're going to start out drawing a two-dimensional sketch, and then we're going to extrude the sketch into a third dimension, and that's how we're going to create the 3D object. So I've already got sketch selected here, sketch mode. Now remember, the geometry of interest was a rectangle. An 80 by 4 rectangle. So I'm going to click on the rectangle draw tool. I'm going to click here on the origin. So one corner of this rectangle is going to be at the origin, and then I'm going to click and hold, and I'm going to drag outwards. And notice I've got this rectangle that's growing as I pull the mouse away from my click point at the origin. Now I'm going to stop right here. I need an 80 by 4 millimeter squared rectangle, but I'm going to let go of my mouse and just point out a feature that'll let you get the exact dimensions that you need without too much dragging. So right now I've got 22 millimeter by 22 millimeters. It's a square two-dimensional object. I've got 22 millimeters highlighted, and I'm just going to use my keyboard to type in 80 millimeters. So that's the length of my sample coupon. And then over here, I'm going to type in 4 millimeters. That's the width of my sample coupon. And now I've got the long, thin coupon that's indicative of the actual object that I'm interested in modeling. Now, this has sort of made its way off the screen, so I need to recenter things. I can use the roller ball on my mouse to zoom in or zoom out. But if I zoom out, I get a little bit too far away, so I can move up here to the pan and the spin function to kind of move this around and manipulate it. So I'm going to click on pan, and I'm going to center this, and then I'm going to zoom in on it and pan and zoom in on it a little more so that you can actually see what I'm doing. Okay. So I'm going to unclick pan, and I've now got a two-dimensional sketch, a 4 millimeter by 80 millimeter rectangle, and so now I need that third dimension, the height. And so what I'm going to do is I'm going to select pull, which allows me to take a two-dimensional object and essentially pull it into the third dimension. So I'm going to click on this. I'm going to hover over my two-dimensional rectangle, and I'm going to look at the arrows, which indicate that if I click and pull, that it will extrude into the Y direction, which is the third direction. So I'm going to click and hold, and I'm going to pull, and you can see it extrudes. Now this is much thicker than it needs to be. 13.77 millimeters is huge. Remember, this dimension is actually just 0.9 millimeters. So I'm still holding down the mouse button. What I'm going to do here is, as I'm holding the mouse button, I'm going to type this dimension into the keyboard. So this is 0.9. The units, of course, are millimeters. I'm going to hit enter, and that gives me my 80 millimeter by 4 millimeter by 0.9 millimeter sample coupon, rectangular geometry, which now that I've drawn it is embedded back within the project, which I'll show you here in a moment. So now that I've got this geometry, I'm going to wander up here and close out of SpaceClaim. And what we'll notice immediately is, remember before this geometry number 2 or number 3 geometry row had a question mark, and now it's got a check mark. What that means is that in drawing the geometry, it's been accepted into the static structural model, and I'm ready to move on to the modeling process. Okay, so I've now just exceeded 10 minutes of my video, so I'm going to take a break here and come back and start a third video where I will show you guys additional steps in the ANSYS modeling process. So take a break. When you're ready, come back and start the third video. Thanks. See you soon.